For Lesson 7 of our expressions unit, we'll be talking about translating real-world expressions. Expressions are often used in real life to describe situations involving comparisons, and we'll see what that means in a second. When translating verbal descriptions, meaning words, to algebraic expressions, meaning math, we can ask ourselves two questions. What is being compared, and what will the variable represent or stand for? So if you want to turn words into math, figure out what's being compared and what your variable is going to stand for. Let's take a look at the first example to practice this. Number 1, Simon has 4 more cookies than Lucy. First question, what is being compared? In this case, it's more like who is being compared. We have Simon and we have Lucy being compared to each other. Specifically, we're comparing the number of cookies that they have. All right, so we answered question 1. Question 2 is, what will the variable represent? To figure that out, we have to look at the sentence structure, like in ELA. So Simon has 4 more cookies than Lucy. So whatever Lucy has, Simon has 4 more than that. So if we don't know how many Lucy has, we can't figure out how many Simon has. So start right away with your variable representing Lucy, because Simon's number of cookies is based on Lucy's. So let's just say Lucy is L. Okay, how can you explain the number of cookies that Simon has compared to Lucy? Well, go back to the question. And this is where we're going to pull in those keywords and what we did in an earlier lesson. I see 4 and then more than, meaning plus. So Simon has 4 more than, and we said Lucy was L. So 4 plus L represents the number of cookies that Simon has. And what you can do with this expression is actually figure out, no matter how many cookies Lucy has, how many Simon has. So if you say, oh, Lucy has 10, then 4 plus 10 gives you 14 for Simon. Or maybe Lucy has 100 cookies. Simon has 4 more than that, so he has 4 plus 100, which is 104. That's how that expression would be used. Now for number 2, Gary weighs 12 pounds less than Jeff. So I already underlined Gary and Jeff are the 2 people being compared here. And again, just like before, Gary weighs 12 pounds less than Jeff. We have to know Jeff's weight before we can figure out Gary's. So let's write Jeff, or his weight, as our variable. So Jeff, specifically his weight, is represented by J. All right, now how could we show Gary's weight compared to Jeff's? Now go back and annotate your problem. Gary weighs 12 pounds less than Jeff. So remember, less than was a subtraction word, but it did that weird thing where it switched around. So we need to somehow show Gary weighs 12 pounds less than Jeff. We can't write 12 minus J. We have to switch it around because it says less than. It would be J minus 12. So whatever Jeff weighs, take away 12, and that's Gary's weight. Variables should represent the part of the situation in which you are given the least amount of information. Usually, if it's just one sentence, the variable is the thing at the end of the sentence, like we saw in number 1 and number 2 with Lucy and Jeff. Let's take a look at number 3. We're going to practice defining our variable and then translating from words to math. So number 3, the width of a box is twice as long as its length. So the 2 things that we're comparing are the width and the length. Now we need to know which one to represent as a variable. And to do that, we want the thing that has the least amount of information about it. We know that the width is twice as long as whatever the length is. But we don't know the length, and we don't know anything about the length. So let's call our variable L to stand for the length. We're not going to say, oh, the width is W. We only want one variable. We're not ready to start talking about two variable math problems yet. So let's represent the length. Well, we already did that. It's just L. Let's represent the width. In the problem, it says twice as long as the length. So that would mean 2 times the length. So the width is going to be 2 times the length, or 2 times L. And if you'd rather, you could also write that as just 2L. Number 4, the 80 brownies sold at the bake sale were half the number of Rice Krispie treats sold. So we've got brownies and we've got Rice Krispie treats. Now we need to figure out which one of these two things that we're comparing do we know the least about, because that's going to be our variable and we'll represent it. So we know that there's 80 brownies. It literally tells us that there's 80 brownies. So let's go ahead and make our variable stand for the Rice Krispie treats instead, because we don't know anything about that. So we'll say R equals number of Rice Krispie treats. So looking here, represent the number of Rice Krispie treats, that's just R. But for the number of brownies, we have to be a little bit more complicated. We need an expression. So the 80 brownies that were sold were half the number of Rice Krispie treats. Remember, of can mean multiply when it's written by itself. So half of the Rice Krispie treats is equal to the amount of brownies. So half of, meaning multiply, the Rice Krispie treats, which is R, gives us the amount of brownies. You could also write this as 1/2 R. And yes, it is true that the number of brownies is 80. So it is possible for you to actually fill in that 80 and solve this, but it's something that we're not quite at yet. It would look like this, and you'd actually have to solve the equation to get the final answer. If we knew R, it would be a lot easier, because we would just take half of it, and that would give us the number of brownies. Last two examples here, we're just going to do 5 and 6, and we're going to do the same thing. We're going to change the words into math. So to start, we need to figure out what we're comparing. So in number 5, Allison sold 12 more boxes of cookies for the fundraiser than Evangeline. So I see Allison and I see Evangeline. So we're comparing, again, the number of cookies that they sold here. So Allison, we know, sold 12 more boxes than Evangeline. We don't know anything about Evangeline. So we're going to use her as our variable. And again, typically the end of the sentence is where we're finding that variable. It's just the structure of an English sentence when you're making a comparison. So that should help if you're ever not sure what to use as your variable. Boxes sold by Evangeline is E. So represent Evangeline down here, just E. Now for Allison, we have to go into the problem a little bit more. She sold 12 more boxes than Evangeline. So there's a little extra words in here, but it really just says Allison sold 12 more than Evangeline, meaning 12 plus Evangeline, or 12 plus E. So there we go. If we ever wanted to figure out how many Allison sold, we would just take whatever E is equal to, whatever Evangeline sold, and then add 12 to it. So if Evangeline sold 50, then Allison sold 12 plus 50, she sold 62. And that is what the expression will do for us. All right, number 6. Xavier's 85 on his math test was 37 points less than twice the grade on his English test. I only see one person's name here. So we're not comparing two people. What I did notice was that there was a math test and an English test. So we're actually comparing the grades on those two tests. All right? So he got an 85 on his math test. So just like before, we actually know the grade on the math test. We know a lot of stuff about that math test. So that's not our variable. Our variable is going to be E, grade on English test, because we just don't know anything about it, and the math test is being compared to the English test. So that's E. So I'll represent the English test down here at the bottom, E. All right, now how about the math test? A little bit more complicated. Yes, it was an 85, but we want to compare it to E. So 37 points less than, just subtraction, but it gets flipped around, twice, got another keyword, the grade on his English test. So twice means times 2. So 37 points less than twice the English test. So let's start at the end of that, twice the English test. If I wanted to say twice the English test, I would say 2 times E. And now we want 37 points less than that. So we don't want 37 minus, we want to flip it around, and it would be 2E minus 37. You could also write this without the dot if you wanted to. Okay? And again, just like up here, we actually could solve this. We could fill in an equation and say we know that the math test was an 85, and we also know that the math test is represented by this expression, and we could solve this, but that actually is more of a 7th grade level equation, so we won't be looking at anything like that this year. All right, and that's it for today's lesson.